All right, so here we are in our next week. Last week you looked at the merge sort, and you kind of looked at how to write a recursive linear search. We're going to do another recursive sort, which is called the quick sort. You're going to look at a video for that, and then you're going to write a binary search, and you're going to do that recursively. So it's the same kind of general mechanics as last week, but you have different algorithms that you're going to implement. So when we're looking at this, what you're going to see with your quick sort, the quick sort is a little bit tricky to kind of wrap your head around. But basically, you select everything that is what's called a pivot. So you have this idea of a pivot. And a pivot can be any element that you want it to be. But basically, you take a value, and let's just say you take something in the middle of your array, and you move everything that's smaller than that pivot to the left of it, and everything that's bigger than it to the right of it. And then you select another pivot, and you move everything that's smaller than that to the left, and then everything that's bigger to the right. And by the time you've all the way done, everything has been the pivot. Since you've moved everything to the left or right based on whether it was larger or smaller than every value, you have sorted your array. And it works out that that's a really efficient sort, aptly named the quick sort. We haven't had time this year to talk about big O notation, but it's a really efficient, efficient sort. And the video that you're going to watch really just kind of goes through that, and is a good way to kind of view what's going on here as this is happening. So same as last time, you're going to, in your lab, what I'm looking for you to do is go ahead and find a quick sort for Java, and you're going to find that code and then identify for me, if this thing is going to load, the base case and the recursive call. So again, for the quick sort, you're going to find that. And then what you're going to do to write some code is you're going to write a recursive binary search. So a binary search is basically how you would efficiently play guess my number. So if I was to give you, said I'm thinking a number between 0 and 100, your first guess would hopefully be 50. And I would tell you if that's too high or too low. And so if 50 was too high, that means that everything above 50 is also too high. And so your next guess would be 25. And so if you think about where that's coming from, what you're doing is basically you are lopping off half of the array every time. And then you're recalibrating what your middle is. So when I told you it was just between 0 and 100, 50 was in the middle, and that was your choice. When I told you 50 was too high, 25 is in the middle. And depending on whether that's too high or too low, then you would calibrate your new middle value. So basically that becomes our binary search. It's really efficient in that we don't have to guess. If you think about like the linear search where you have to guess every element and you could potentially go through every element in the array before getting it. This one, you wouldn't have to do that. Basically, you want to know how many times can I divide this in two. The key with that, though, is that the thing has to be in order. So it has to be ordered before you can do a binary search on it. If there's no order, it doesn't make any sense to get rid of half of the values at a time. But this video will walk you through that. And you're just going to basically put your summary there of the binary. I shouldn't say binary sort, it's just a binary search. All right, I'm going to make another video in a minute showing you how the replit piece works. But hopefully that takes you through kind of, again, we're just looking at the overview of these sorts, and you're just going to familiarize yourself with the recursive call of it. All right,